Hi, our project on sentiment analysis on Amazon Fine Food Review. The goal of this project is to automatically classify customer reviews as positive or negative. The problem statement of this project is customer reviews are extremely valuable for business, but with thousands of reviews, it is almost impossible to manually analyze each one. So our challenge is to build the model that can automatically classify these reviews, helping companies quickly understand their overall sentiment. The goal is to create the system that can efficiently identify whether the review is positive or negative based solely on the text of the review. This code is demonstrate how to build and evaluate the convolutional neural network model for sentiment analysis using Amazon Fine Food Reviews. Let me walk you through the step-by-steps and explain the key concepts involved. In here, I have imported the necessary libraries and then loaded from the CSV file contain the customer reviews text and their rating score. So the new column sentiment is created based on the score. The reviews with score 4 or 5 are considered positive and reviews with 1 or 2 are considered the negative. So the review text is tokenized and each sequence is padded to a fixed length to the 100 so that all reviews have the same size, making it easier for CNN to process the data. When we consider about the CNN model, they're built with 6 layers. Those are embedding layer, convolutional layer, max fully layer, flattened layer, fully connected layer, and output layer. The model is compiled with the Adam optimizer, a popular optimization algorithm that adjusts the learning rate during the training. The loss function is binary cross entropy, which is suited for binary classification tasks and accuracies used to the evaluation metric. The accuracy of this model is 93.75%. So the model is trained for 5 epochs with a batch size of 64. During each epoch, the model learns a pattern from the training data. Validation data, 20% of the original data is used to evaluate the model's performance after each epoch. When we consider about the evaluation and the visualization, after training, the model's accuracy test set is involved. The plots, the training and the validation accuracy is monitor the performance. So in here, it displays the convolution metrics showing how well the model predicted positive or negative sentiment, and also print the classification report that includes precision, recall, and F1 score for both positive and negative class. Finally, the model is tested on the new unseen reviews. The text for these reviews is tokenized and padded to the same way the training data, and the model predicts the sentiment for each review. Key optimization techniques that I have used Adam optimizer. This is the advanced gradient descent algorithm that adjusts the learning rate for each parameter based on the first and the second movements of the gradient. It combines the advantages of undergrad and RMS propagation, and also use the dropout to avoid overfitting. The dropout layer is included, which randomly sets 50% of neurons to 0 during the training, encouraging the model to generalize the better. Thank you.
Hi. In this part, we will walk through the key steps of building the sentiment analysis model using LSTM on Amazon Food Reviews. We use TensorFlow and Keras deep learning, focusing on pre-processing, building the model, and interpreting the results. Here you can see the necessary libraries are imported, and here the data loading part, and after that the pre-processing part. We have used the tokenization and paddings for data preprocessing. We first import the dataset and preprocess it by using only the review text and sentiment scores. We label reviews with scores above 3 as positive and below 3 as negative. Then we tokenize the text into sequences and apply padding to ensure uniform input length for LSTM model. And after that, the LSTM model is built using Keras sequential API. So it starts with an embedding layer that converts words into dense vectors, followed by LSTM layer to capture sequential dependencies, and then a dropout layer to prevent overfitting, and then a dense layer, fully connected layer for binary classification. And then we have trained the we have used the Adam optimization binary cross entropy for compile the model. And then we have trained it using 5 epochs and 64 batch size. Then we have got this accuracy 93.86%. We have tested before and we got 83, and we have improved that from using these optimization algorithms and this in user activation functions and hypothesize hyperparameters changes. And then here you can see a classification report we got through test data set, and you can see a precision recall, F1 score, and support with the positivity, negativity, and accuracy in matrix. And then we got the graphs, distribution of review scores with count, and distribution of sentiment with count, and number of words with the frequency, and here the model accuracy graph, here the model loss graph. And finally we got the confusion matrix using Seaborn and scalar matrix. And here it's finally the we have tested using unseen data to test our model, and we here you can see all the models are mapped into correctly positivity, negativity with the probabilities. That's it for the LSTM model. Thank you.
I choose a deep neural network because it efficiently captures complex patterns in text, enabling accurate sentiment classification. To preprocess the data, I tokenized the reviews, limited the vocabulary to 5,000 words, and the padded sequence to maximum length of 100 to maintaining to ensure the faster processing while maintaining useful information. And I used the embedded layer to 64 to convert word into vectors, followed by dense layer with value activation. And it optimized for speed without losing much accuracy. And I included dropout layer with 30% dropout rate to prevent overfitting by randomly deactivating neurons during training time period. And I used Adam Optimizer for faster convergence and implemented dystopins with patients to if the validation loss doesn't improve. This prevents overfitting and reduces unnecessary computations. And adapted into epoch to 5 and increase the batch size to 64 to optimize this model. And this is the data visualization part, and this is the charts, and this is the training and validation accuracy, and this is the training and validation loss. When we discuss about this accuracy, this is the 91.41%, and this is the classification report. It is quite strong and indicating the model is performing well overall by this percentage. And the predicting sentiment displaying predictions, evaluating the accuracy and visualization results through a confusion matrix. The code provides a comprehensive approach to sentiment analysis, and this shows 91.52%, and this is the confusion matrix. And the code snippets demonstrate how to use a trained sentiment analysis model on new reviews. It preprocesses the reviews, predicted their sentiments, and outputs the predicted sentiment along the associated probability. And this DNA model is notably fast with 29 milliseconds, provide quick predictions, which is essential for evaluating the performance on unseen data and make it valuable for real-world application.
In our project that used the Amazon Fine Food Reviews dataset, I chose a recurrent neural network for sentiment analysis because RNNs are particularly suited for sequential data like text, where understanding word dependencies and contextual information is crucial. RNN can maintain a hidden state across different time steps, making them excellent for capturing patterns in user reviews. In preprocessing and optimization to prepare the dataset, I tokenized the reviews, reduced the vocabulary to 10,000 words, and padded the sequence to ensure uniform input length. This reduced the model's complexity and ensured faster computations while preserving the important data patterns. The model architecture, the RNN model I built, starts with an embedding layer which converts words into dense vector capturing the semantic meanings. This is followed by an RNN layer with 128 units where it processes each word sequentially. By leveraging RNN's inherent ability to store contextual information, the model captures sentiment from the reviews text. Additionally, I used dropout layer with a rate of 0.5 to prevent overfitting by randomly deactivating neuron during training. Training and optimization. The model was trained using an LM optimizer for faster conversions. To ensure efficiency, I employed early stopping to hold training where there was no significant improvement in the validation loss, thus preventing overfitting and unnecessary computation. After training for 5 epochs, the model achieved strong performance with an accuracy of 93%. If you evaluate the performance, the model performed sentiment classification with an accuracy of 93.72%. It achieves a precision of 95%, a recall of 97%, and an F1 score of 96 for positive sentiment classification, showing its strong ability to correctly predict positive reviews. The inference time of just 35 milliseconds ensures that the model can be used effectively for real-time applications. In conclusion, the RNN model efficiently captures the sentiment in text reviews, providing useful insights for customer sentiment analysis. Okay. Finally, if we consider the all four models used for the sentiment analysis based on the result and the model comparison under different parameters. In conclusion, while LSTM stands for its high accuracy and recall, particularly in capturing long-term dependencies in text, CNN and RNN offer a balanced trade-off between performance and speed. CNN excels in precision and inference time, making it a greater choice for time-sensitive tasks, while RNN delivers a similar accuracy but with a faster predictions. DNN, though the quickest to train and infer, lacks in overall accuracy but can still be useful in resource-constrained environments. Ultimately, each model serves its purpose depending on the specific requirement of the task. Thank you.